much for joining us here on AU Manufacturing Conversations.
Yeah, a pleasure to talk to you.
The first question for you, as it is for all the guests, is how did you get here and what do you make?
I started as an engineer, well, an engineering student, I should say. So Monash University, graduating in 2003, so it seems like a long time ago. You always dreamed of being an engineer, but what I actually ended up being was a salesperson, right? And I worked for world-renowned company Flir Systems, who are the global leaders in thermal imaging camera systems. Not, I guess you'd say, a traditional sales role, but very much a technical sales role. What that did was that led me to meet some wonderful people, all right? Great scientists at Defence. In 2014, I had the opportunity to leave Flir, not that I left them on bad terms, but to start my own company. One of the first things I did when I started my company was to pursue a project that had started with the guys in Defence way back in 2005, and that was to commercialise a stress imaging camera.
What was the name of your company?
I left Flir in 2014 to join a company called LRM Technologies.
Yep.
Right, so LRM Technologies focused on lasers. Right, industrial laser systems for engraving, for marking, for cutting. Very much mainstream now in Australian manufacturing. You can barely go to a workshop, an engineering fabrication shop, without seeing a laser of some type. Right, so again, very much sort of in the vein of engineering and fun toys. That's really what I'm all about. But one of the things I didn't want to do was to touch base with the guys at Defence. Because of this stress imaging technology they had come up with.
Right. And 2005, did you say that?
Yeah, so I'll give you a little bit of history then.
Please.
The FA-18, the Hornets, which is quite topical because we're at Avalon at the moment. In 2005, they were coming to end of life. The Australian Air Force had a decision to make. Right? It was going to be a costly choice no matter what, because the replacements were still another couple of decades away. Right? We're seeing F-35 Joint Strike Fighter now just coming into our fleet. And so there was a life extension program implemented because we had to push these FA-18s beyond the usable life, or we had to buy new structures, we had to buy new center barrels for these aircraft. And so the scientists at Defence, whose tasks were to understand the fatigue life of these aircraft, embarked on a program to, I guess, manage, to map out the fatigue of these aircraft and see whether they needed to buy new center barrels or continue to use the current ones, but with a very, I guess, detailed maintenance program. And one thing they realized was the current technology to understand fatigue, to understand the stresses and strains on a structure was too limiting. The current technology, the traditional technology, are strain gauges. Right? We're talking about very robust but simple devices which were developed back in the 40s. So they're not exactly cutting edge, but they do work. What the Defence guys really wanted to do was find a way to see the stress concentrations, to image it. Because what that would do is it would essentially just give you hundreds and thousands of stress points, hundreds of thousands of strain gauges. With that much information, with that much detail, you can make such better and informed decisions. And I'm sure it's documented, but I think it's in the order of $400+ million worth of savings to the Australian taxpayer because we were able to extend the life of these structures.
So that's the beginnings of it? Tell me about spinning the company out or the IP under license. That was like 2017?
First, even before that, when I was working for Flir Systems, one of the things we really wanted to do locally was to bring that technology into the Flir company. Unfortunately, we're in Australia and headquarters is in America, that the progression of that discussion didn't go the way we wanted to. So I was a little bit disappointed when I was at Flir that we couldn't do anything further at the time. So when I did leave Flir and started with LRM, that was one of the first things I wanted to rekindle because it was such a great idea. It was an idea that so many people just didn't believe could work. It was something that I saw, I had front row seats to right from the very beginning, and I had a bit of a passion to make sure that this great Australian idea actually made it to market. And I think the other key point to this is the team in Defence wanted the same thing.
Tell me about how it works, roughly speaking, hugely technical terms, because I'm not a hugely technical or vaguely technical guy. You're watching an object, you're putting it in some kind of big press, and you're looking at heat maps that come up that are based on conversion of strain into heat.
I'll give you, I guess, simple layman's term, explanation of it all. So I think most people understand if you compress a gas or you expand a gas, it'll change. It'll heat up when you compress it, it'll cool down when you expand it. It's how refrigerators work, it's how air conditioners work. Very well known. What a lot of people don't realise is that the same thing happens on a solid. If you compress a solid, it heats up. If you expand a solid, it cools down. The big difference is that the temperature changes are tiny, right? As opposed to being able to change a gas temperature by many degrees, we would only be changing the temperature of a solid by a few thousandth of a degree. Or, in other words, a few millikelvin, right? Hence the name, correct. And so what happens especially in an aerospace testing program, is that you will do a fatigue test. You'll grab a part or a component and you will apply a force to it that represents the force it will undergo in real life. So during that test, that part will be stressed and will start to give off temperature rises and temperature drops, but at such a small scale that nobody can detect them. And there is no sensor in the world, no temperature imaging sensor in the world that can just natively pick up this temperature change. So what we realized, or the team at Defence especially realized, was if we know the frequency that we're applying the force, if we know every time it's under compression, every time it's in tension, then we can just pick out the temperature changes at those points. So there's a lot of clever math, there's a lot of clever image processing, but essentially we just think of it like a Where's Wally book, where every time you turn the page, Wally doesn't change, but everything else does. So as you turn the page enough times, Wally starts to come about and become a lot more prominent. That's what happens. You give us enough time, a lot of image captured, and we will always show you what's available at every compression and tension cycle.
That's a good job of putting it in layman's terms. I think Where's Wally is about my level. Good job finding it. You showed me earlier some prototypes that were developed through a project backed by the Advanced Manufacturing Growth Centre and involving some other parties.
Yeah.
Tell me about that, please.
This journey was really interesting for me. An engineering student, a salesperson, always technical, but I've never built a product. But excuse us as the planes go by. And so my key role in this whole project, in this development of product, is to bring a commercially ready product to market. Right? A great idea, I wanted to bring it to life. That would only work if you built an elegant, easy-to-use product. That was always the goal. And I quickly realized when I started the journey that I don't have the skills. We had the ideas, we had the direction, and we had some really smart people helping us at Defence, but we needed the implementation. When we built the products, we engaged the team from Outerspace Design. So a nice local Melbourne company like we are, who I really got to know well, and we've worked extremely well together. The first product, I would say, was a bit of a learning curve for everybody. Right? The team at Outerspace probably never quite understood my vision too well, and I never understood the process of building a new product very well either. But together we learned so much, right? And we brought to market a really nice product, one which you just plug in a few cables to, you press start on our software, and within seconds you get the stress image. But my goal was to build something a little bit more smart, a little bit more compact and rugged as well. Most people see our first product and think, whoa, that's small, but it's still too big for my liking. Thanks to the guys at the Advanced Manufacturing Growth Centre, the AMGC, we actually set on a new project, which is to develop what I'll call Product 2, and that's sort of the one I'm really proud of. The reason being that in Product 1, we have a camera system and we've got a software that we run on a computer, and it works great in a lab environment. It's got a USB connection, nice and standard. But if you want to take this outside of the lab, if you want to put it on a vehicle that's in service, that's flying perhaps, you need something a little bit more rugged, and you can't have a laptop tethered to it everywhere you go. We had some great help from the AMGC, and we set the guys at Outerspace a really strict target. We gave them a small operating package size to work within. We gave them really high specs for what the performance of the camera needed to be, and we worked with them and the guys at Defence to realise what is a neat camera system, which is smaller, more higher spec than our first product, more rugged than our first product, and encompasses all the smarts that you could ever need, so that this is now a standalone smart stress imaging sensor.
So you mentioned use in the lab. Most of your customers sort of researchers at this stage?
Correct. Today it's used by the guys at Defence in their testing labs, by the guys at RMIT again in the testing labs, and it works great for that. The reason for product 2 is because that architecture, that platform that we develop will allow us to reach a wider engineering audience. It's more suitable for the guys that are developing all manner of vehicle. It's so much more versatile, easy to deploy. If you wanted to cover a large structure with smart sensors, you could easily just take a handful of these, couple them directly to the structure, and let it move with the structure as it's undergoing a test.
So your initial focus is aerospace, and you're obviously at an air show. Tell me about what this can do for aerospace customers, and then further than that, what other plans you have for other markets.
The targeting of aerospace is very much because this is where we've got pedigree. This is where we have demonstrated runs on the board. This has been used on the FA-18 center barrel life extension program. It was used on C-130. It was even used for a little bit with F-35 at Fort Worth in the US. Right? So we know it works. The biggest advantage for the guys in aerospace is that it just reduces the manufacturing time. Right? One of the most critical stages when you develop a new aircraft is you design it digitally and then you validate the real thing. And that process of validation can take years. And having the ability to see stress during this validation stage allows them to cut so much time off that validation stage because you see exactly what the computer simulations should be doing. So there's no guesswork. You just see it. It means you can go back, refine your simulations, and you can save so much time. Instead of waiting, in some instances, for the structure to actually fatigue and crack, we can show you that well before it happens.
I see. So obviously Australia is not an aerospace manufacturing powerhouse. I mean, we have some good companies that feed into the supply chain of OEMs, but we don't have a company making planes here, obviously, at least not on the scale of Boeing. Whatever, we might have Jabber or someone
Correct.
somewhere.
Correct.
Tell me about the limitations of that and what you have to do to overcome that.
That's a big challenge for us. Certainly for certain defence applications it works well, but really where we need to expand to is overseas. Right? It is the OEMs, it is the big primes, the likes of Boeing and Airbus, and everyone else that makes a plane, because they're the ones that will receive the most benefit. And as a small Australian startup, that's difficult because it means we have to reach out overseas. We have to find ways to make those connections, get into the networks, meet the right people from the right companies. And that's difficult. That's been a challenge, but it's been a fun one. We started the journey 12 months ago at the Singapore Airshow. We were privileged then to be able to be one of the delegates with the Team Defence Australia stand that visited the Singapore Airshow. Made some nice contacts, really got to understand the industry and the ecosystem more. We followed that up with a visit to the Farnborough Airshow, again with Team Defence Australia. We're now doing the Avalon Airshow here as an industry partner with Defence, and we'll go to CS Space next year as well, next month in Washington, DC. And that's what it is. It's just a lot of getting your word out there, talking to people, finding the right channels, and eventually talking to someone who knows somebody who knows somebody that gives you the right in to talk to the person that really understands your technology.
Yep, it's just a lot of networking until you find that right in.
Correct, there's a lot of networking, and I sort of find it interesting. I was really chuffed that we won the Innovation Award here. It feels like we've been telling the same story for the last 12 months. And slowly but surely, a few more people have listened to the story, and a few more people have told other people about the story, and finally after 12 months that same story has resulted in a little bit more actual publicity. It's sort of been the culmination of a lot of hard work, a lot of talking to people, and just a lot of great people that we've had partnerships with.
And you mentioned you're a small team. How small is that team?
Officially we're 2 full-time employees, right? But just to say we're a team of 2 would be remiss to actually talk about the team. The team really is the guys here at 1Millikelvin, the greater team at LRM, Laser Resources, because they helped me fund this project. The team at Defence, those guys have offered us so much help. This product, this technology doesn't become commercialised if they don't share the same commitment that we do. And the guys at Outerspace Designs, they're our contract design house, but I think of them more like our partners. It's more than just a supplier-customer relationship. They understand our vision so much better today. They share that vision, and the camaraderie we have as a wider team, we achieve so much more. And of course, let's not forget that people like the AMGC, they provided valuable funding just to get us to this point.
Would you like to say anything about an issue within manufacturing in Australia that is not getting the attention it deserves?
I think manufacturing in Australia, I guess advanced manufacturing gets talked about a lot, but sometimes I feel like it's just a little bit too surface, you know? We've got great advanced manufacturing research sites around the country, but I think there's a little bit more work to do to actually do it in commercial reality. But you know what? You go and you see companies here at this show, some of the companies that have been at the delegations on the Team Defence Australia stands, you go, wow, there are some great companies that are trying to change this. Whilst we're probably not at the level of some of the Europeans and the Americans, what we are is we've got some really great people who want to change it. So yeah, I think we're on the right track, just a little bit behind.
Lastly, is there a plug you'd like to make, or perhaps a final comment you'd like to offer in closing?
Key to all of this, I know maybe he doesn't like the accolades, but Dr Nik Rajic from DSTG. He was the brains and the driver of this technology right from the outset. His team have been so good with us. And without his drive, this would still be just a really good idea. So yeah, Nick, awesome bloke, and is the big reason why 1Millikelvin and this technology is in the market today.
That's about everything we have time for. Congratulations again on your 2 awards yesterday, and look forward to watching your progress.
Yeah, cheers. Thanks for that, Brent.